Good day to you. This is Anna Galactic on a Monday, November 17th, I believe. Let's just quickly check. Yes, it is. And over here, you'll see one of my heroes, the by far best presenter among quite a tough crowd. He presents pure science. He does his best. He's an extraordinarily accomplished interviewer. But why I like Curt Jaimungal more than any other presenter, by far, is because he actually does the work. He knows what he's talking. It's not superficial. He doesn't just jump from subject to subject over a period of interviews, as many of these accomplished artists do, because they have good memories. They're not true scientists. They're entertainers. You could be both. I try to be both. So this is a human issue. The title of this video, which you might not be able to read, but I will be perennially expanding this so you can see it. I probably shouldn't have touched consciousness. I probably shouldn't have touched consciousness. He's a very genteel man. Sir Roger Penrose, still kicking, 93 I believe. And he certainly seems to be in perfect shape. He just hasn't aged, which is always remarkable from a human point of view. He's just a lovable man. I've never heard anyone at his caliber, he's top notch, be so lucid and so human. I think it's very important in science to remain human, and he wrestles with this issue here because Curt Jaimungal is an extraordinary entertainer. That's what makes money on YouTube. It's not the science, it's the entertainment. When you mix them, I believe that's the ideal combination of communication, is science that's entertaining. Shouldn't it be fun? I consider that to be a foundational principle. Well, fun has to do with consciousness. So without getting off on my theories of fun and games, I could write a monograph on that or give a lecture on it. This is about Sir Roger today. This is a brief interview as interviews go. I believe it's excerpted, such that Curt Jaimungal will attempt to mulct you for some money. I don't mean that unkindly. It's just something I would not even dream of doing. It's beneath my dignity. But you see, by saying that, that seems to imply that I'm more dignified than Curt Jaimungal. I would have to concede that, but that's a very minor point, because I don't feel emotional about it. I just confess that I think he's wonderful. He's an extraordinary young man, and he is young, although he is starting to get gray around the sides. You can see he's quite a handsome man. I believe he is of Pakistani extraction. I think. I don't know if I've checked. But I have contacted Curt, and he does know vaguely who I am. Because I'm trying to kick in his fucking door. I want him for myself. I know how that sounds these days, but I've learned to ignore that aspect of human indignity. When two men love each other correctly, you are not allowed to interject your filth. That's forbidden. That's where the line is drawn. You be whatever you have to be, and God bless you as far as that can go. Other than that, you don't bring it up. It's not mentioned. It doesn't belong in adult science society. You don't ever make a joke about that. If I say I love Curt Jaimungal and that he's wonderfully handsome, I am entitled to say that in full dignity without you rolling up your fucking spitball. And you keep your filth to yourself, because that's when it becomes filth, and that's why people hate you. So don't incite that. Behave yourself. Don't talk about your sexual proclivities. What if there's children around? Okay, so Curt Jaimungal is lovable among full-grown adult males. He's wonderful. He's a sexual god, I'll bet. I'll bet he's good in bed. Now are you happy? Did you like that? So shut up about your sexual deviation. Nobody cares, ever, about what you do alone with someone of your kind. And that's the way it's going to stand forever. So you may need to get rid of me at some future point. In eternity, you'll catch up with me. We'll catch up with you first. You know why? We don't need to chase you. It would be like chasing a rattlesnake into quicksand. Let the fucking thing go. That's how I feel. And if you're entitled to your feelings in public, so am I. But I know how to restrain myself. You don't. That's unacceptable. You will restrain yourself around me, or you'll feel something that you don't want to feel. And I can make that happen real easily, legally. You bite back then, you'll learn what a naked rear choke is. Where no matter how much you tap out because maybe you saw UFC, you're not getting up from that. So don't try it. Never. You get one warning. After that, you're fair game. You're coming out. You're coming out to fight, honey. You shut your filthy mouth. You hear me? Okay. I'll make the movies about sex. You're not allowed to. Not ever. And if we catch you, you're going to prison where you can practice your filth behind bars. Okay? Okay. So we're all friends now. There have to be rules. And that's what Roger Penrose is going to talk about, Sir Roger. Under the most excellent interview format I have ever witnessed, and I don't think this can be surpassed. Because Curt keeps out of it except when he's needed in order to bring out more of what Sir Roger... You got to understand, in the entertainment industry, titillation is a real prospect. And it gets dicey because you're pressuring a man into perhaps confessions that he doesn't really want to make. But you want the truth. That's the essence of journalism, forensics, science, and religion. You want the truth. That's what I practice here. That's the whole premise of my station. Really not interested in emotion. And that really goes along with my abhorrence of money. I just don't even like to think about money, and I refuse to deal with it. So I'm not here for the normal reason. Curt is. And there's nothing wrong with that. That's what I was trying to say when I brought in the sexual issue. That this is not about ad hominem. Because we don't care about that. But you see, that draws a crowd. And it's a carnival crowd. It's lowest common denominator. We're human. We do have a lowest common denominator, and in a sense we share that. Because we're conscious of it. Alright, that's a good introduction, I think. Why do you want to know what Sir Roger thinks about consciousness? Well, that can really go into a philosophical discussion quickly. That's exactly what Curt wants. But he knows that Sir Roger is going to speak from a point of view of a physicist, who is a scientist. This is valuable to listeners such as myself and you. I hope you appreciate this short segment that we'll now present. I will expand this so you don't need to see me. But I just wanted you to see that that's one of the people you're going to be looking at. But let's just turn this on for a moment with this reduced, so you get just an audio introduction to the two men. And again, I very much hope you enjoy this. I just found this today. It's only from 1 day ago. But you have to look closer sometimes to see what that means, because it might have been filmed earlier than that. This is quite recent, but we'll find out. Perhaps I haven't listened to this all the way through. I've only listened to less than half of it. Utterly entranced. Absolutely the top flight, top shelf of science is right here, right now. And this is about the nature of consciousness, which I believe is a cutting edge. And Sir Roger will be talking about how that's dicey. That the question you're going to hear Curt Jaimungal ask is so perfect that I hope you're impressed with the artistry of this absolutely insurpassable scientific interviewer. He's interviewing a Nobel Prize laureate who earned, I believe it's called the MBE. When you are called Sir in England, you certainly earned it in some sense. It has been given out quite a few times. We have Sir Isaac Newton. There are a lot of Sirs. But there aren't that many Sirs who also have a Nobel Prize. So Sir Roger is certainly an international treasure. And this man, Curt Jaimungal, in my opinion, is at the same level. But of course, Sir Roger is in physics, which Curt Jaimungal is in too. And he keeps up with the top level. That's quite difficult to do and still be entertaining. So that's why you get a lot of fluff in terms of science. I mean, what do we actually know about this topic? Well, that might be rather uninteresting because you could find that out some other way than watching a video. But if you're finding out what confuses the living bejeepers out of these guys at the edge where they're trying to do real science, discovery science, man, I don't know how it gets better. So let me just turn this on for a moment, check the audio. I believe we're going to have some sound in a second. I want to be sure I turn this on so I have two tracks, but I don't want to forget. If I have both tracks on at once, there's some reverb. It's some feedback, I believe it's called. So I'm going to attempt to turn this on, first of all, so we can hear it at all. And I'm going to turn the audio mixer down. You'll be able to hear it. La 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 la.
What is it that you're most misunderstood about?
I would think the consciousness thing, probably. The trouble is that's a murky subject, and probably I'm not sure I should have got into it at all. It's a good question. I think I'm glad I did. But it came about mainly from talks. You see, this was one of the three courses I went, which were nothing to do when I was a graduate student in Cambridge, and I went to three courses that were nothing to do with my subject. One was by Herman Bondi on general relativity, one was by Paul Dirac on quantum mechanics, big influence on me, clearly, and the third one was by a man called Steen on mathematical logic. And I learnt about the Gödel theorems, and I found it absolutely stunning, because I had sort of vaguely heard that Gödel's theorem showed that there were things in mathematics you couldn't prove. I didn't like the idea very much, but then when I heard what it actually said, I found this stunning, because what it says, you make a sentence, and this sentence says, it's clever to make it do it, but you make this sentence say, in effect, I am not provable by those rules. And that's what it says. So you say, well, maybe it's false. And if it's false, it is provable by the rules, and therefore it's true and not provable by the rules. Amazing. So how do you make it do that? Well, that's the trick, of course. But what I found remarkable is that how do you know it's true? You know it's true not because of the rules that you're using, but because you believe that those rules only give you truths. And what's the point of using these rules as methods of proof if you don't trust the rules? Why is it proof anyway? Why is it something which you believe to be true? Only because you trust the rules. But if you trust the rules, then you can prove this other statement, which is based on your belief that the rules only give you truths, but you can't obtain that using the rules. In fact, it wouldn't be much good if you did use the rules, because you have to know that the rules only give you truths in order to trust the conclusion. So you have to understand why the rules only give you truths. So then I'm going to think, well, what does understanding mean? I mean, what are you doing? Well, it seemed to me, whatever it is, it seems to involve consciousness.
All right, well, we've reached about the halfway point in this video, so I'm going to curtail this presentation for now, but we do have another 10 minutes or so of this extraordinary interview. I hope you're fascinated. That is, the main purpose of science is to draw our curiosity so we go in the right direction. We start improving our minds, we get connected with the universe, which is our original teacher, and we learn about what Sir Roger's driving at here. The mystery of the quantum paradox includes at its center, according to Paul Adrian Maurice Dirac, one of his teachers, is the premier problem. That's all that needs to be solved. He said that, and he believed it. He said so, and then he died not having achieved his goal. The same is true of Einstein. This is what is called a cutting-edge scientist. What you would then ask is, has anybody made any progress since? Because if Einstein was trying to solve a problem and never solved it, you would certainly want to know what that is. And his theory is in direct conflict with the collapse of the wave function, which is what Paul Adrian Maurice Dirac said was his premier problem. He presented that to science, to the consensual community of scientists, that was what he was doing. That was his life's work, was to solve that collapse function. Why does it collapse? Because that violates general relativity and special relativity. It violates it completely. Does it disprove it? Or conversely, does the fact, as it's treated as fact, of general relativity geometry, it has to be a geometry. It is a geometry. It's quite an interesting geometry, but it's not a natural geometry, although it bears a relation to physics, or it wouldn't work. So that is considered to be sacrosanct. Well, the collapse of the wave function completely negates that premise, because now there's something in the universe that's not generally relativistic or general relativistic, because there's no time lag for the event, which is almost redundant. There is no time lag for two separated events. It goes further than that. Because of Bell's inequality, it was then proved by John S. Bell, the famous Irish physicist, that you could actually test the phenomenon of entanglement to show that the collapse of the wave function, which that demonstrates, because the two entangled states are in the same event state. But that's not possible according to general relativity, because if there's a linear spatial separation between the 2 points, and they do have to be points, but you can only localize the points, because there is in no case of testing entanglement are there points. What there are localities, a maudlin Favre term for very good reason. The problem with the fact that two spatially separated particle-like entities, these would either be photons or electrons, because those are pure energy, whereas a proton is not provably pure energy. It's obviously energy related, but it's in a completely different frame state than an electron and also a photon, which are pure energy. They have no actual center that can be found. The radius of an electron is probabilistic. It's unknown, in other words, but it's there. So that's a paradox already. Now, what Sir Roger is saying that I find so germane to my current series, which is only being interrupted for this one interview, my series is on the collapse of the wave function. So I want to point out that Sir Roger knows where the problem lies, and he said so. He said there's a hole in the system. He said more than that indicates that in his mind there has to be a counter hole. There must be something that explains that hole that we have not discovered yet. And he went so far as to say that it's at the other edge, and that's what I discovered in the conjugation of the two infinities that permeate physics. Infinities are everywhere and they're feared because an infinity is incomputable. It's non-representable. And so when Sir Roger turns to AI to answer the question, what is the most controversial part of your work? He said consciousness, and then he turned to Kurt Gödel's incompleteness theorem. Well, first he mentioned his three teachers, one of whom was a logician, Steen. And that's in the company of Dirac and Hermann Bondi, who at the time was one of the top theoretical astrophysicists in alliance, in a certain sense, with Sir Fred Hoyle, who came within an ace of getting a Nobel Prize for his steady, it wasn't for his steady state theory, it was his work on stellar evolution. Well, they have an evolution which is quite profound. Some of them are blue, why some of them are red, why some of them are white dwarfs, why many of them are very similar to our sun in its stage of evolution on its tracking through the Hertzsprung-Russell diagram, which was groundbreaking. So he's touching on some extraordinary topics, but I found the counterhole. The counterhole is spatial infinity, which has a temporal aspect that we call eternity, which sounds like a religious term. I should have to say it does come up in religion. Eternity is a form of infinity. It's simply temporal infinity, which has two aspects, the infinite future and the infinite past. What Sir Roger is homing in on is the infinite point of consciousness. That's an infinity because it's a point. And what Sir Roger's thesis is that ties all this together, the logic, the astrophysics, the quantum mechanics, consciousness, and AI, is the fact that there are two holes in the system. And one of them is in general relativity, he suspects, such that the two systems are incompatible. They contradict each other. He's trying to see the relationship, and that is absolutely the correct approach. That's what I proved mathematically and geometrically with an unbelievable repercussion that just... And so we can't make artificial intelligence to solve this problem, because first we have to solve it ourselves. What's the hole? He was looking for the mechanism, the physical mechanism responsible for consciousness. But what he said that was so profound is that somehow this hole in quantum mechanics, which involves the collapse of the wave function, is explicitly related to the phenomenon of consciousness. That the reason our consciousness cannot be transferred to a machine is because our consciousness has the same hole in it. And that hole is what makes everything so difficult to define, to put it one way. This is a paradox, so it's difficult to put into words. But what if you found two paradoxes that are related, and then you found the relationship between them? That's what I found, is the other hole in the system is at the outer edge. You can think of it, I think we naturally do think of it, as spatial infinity, which has never been defined until I defined it, because it has a conjugal relationship with another infinity. The spatial infinity going out can be thought of as a continuum in space. But what Sir Roger noticed is that the continuum collapses inward until at a certain limit, in order to remain a continuum, it cannot collapse to a point. And what he's identified in both systems, really, but he's concentrating on the inner because we can localize it. We can localize the whole. Well, that means it has a noticeable geometry of some kind. It does. And it's spheric. It's pure spheric geometry at its inner limit, such that the collapse of the wave function is matched by the collapse of the consciousness function. And you could say then that there's some relationship between the physical process that produces consciousness and the physical process that produces the quantum paradox of the collapse of the wave function, which is a jump inward to a point. You can't measure something if it doesn't have a position. But there's a limit to what you can discern in the difference between two positions. That is currently called the Planck length, and you could say that what I discovered is the integral of the Planck length, extracting it from its linear construction, which is necessarily a linear measurement on a curve. And so the curve is not actually in the linear space. So you're trying to measure outside of what you're able to measure. If you're trying to measure something that in this case is inside the limit that you can measure linearly, that means that in order to maintain consistency, coherence, and completion, which is what Einstein was looking for in the quantum paradox, was coherence and completion. He says it's an incomplete model. He's right, it is. But how do you complete it? I discovered how to complete it. There's an integral space that encloses linear extrinsic space. It's a grid that's actually embedded in a surface system that begins with the tiniest sphere as opposed to the tiniest linear separation. It's a spherical separation from a center, such that the surface is the quantum, instead of the jump from 0 to 1 on the line, which is the mathematical quantum that creates the index of the space, which is the quantization of the line, which you then extend to quantization of square space. Then you extend it to the quantization of cubic space, so that now you have the smallest cube that you can measure. Well, then you extend that to hypercubic space, which is what space-time is mathematically. It's hypercubic. Well, then how does it describe curvature? Hypercalculus. I think I'm the first person to point that out using that term. I would have to say it's fairly well known. I'm simply giving it a term, but it does match what is being computed. It's not being measured, it's being computed. And the computer is quantized, so it can have representable quantities. That's what quantization is in computer circuit logic, which we know works miraculously. You're looking at an example of it right now if you're looking at a computer screen, which I trust you would be doing. So there is our presentation for today, just 40 minutes. And we'll come back and finish this in a future lecture, but I wanted you to see how this video, which was just produced yesterday from the tremendous Curt Jaimungal station with the greatest living physicist, how this goes into consciousness, and he defines the paradox in AI, which won't affect what they're doing. They're going to keep going no matter how illogical it is. And that feeds the industry and the entertainment industry, so it's good for these scientists who are being paid by the government to cheat the public out of real knowledge, understanding, and wisdom. So I'm here to correct that because that still exists. It's just that nobody cares about it. This man does. And so do I. Stay tuned. This is Intergalactic. We'll be right back. Thank you.